Welcome. Today we are going to discuss a class of compounds called thiols. This is in the chapter on alcohols because thiols in many cases are very much like alcohols. Thiols simply have a sulfur instead of an oxygen. But that makes a big difference, and many of the properties are quite different, but in a lot of ways they're very like alcohols. So they're called thiols. We're going to talk about naming, one reaction by which they can be prepared, and one reaction that thiols undergo. So it'll be a pretty simple discussion today. First of all, let's talk about naming. There are two systems for naming thiols, just as there are two systems for naming just about everything else. But it's not too complicated because the systems are very similar to the systems that we use for alcohols as well. So in the common system for naming thiols, we're going to call them mercaptans. If you remember, for alcohols, in the common system, we just say the name of an alkyl group and then say the word alcohol, like methyl alcohol, isopropyl alcohol, cyclopentyl alcohol, or whatever. Well, we're going to do the same thing with thiols, except we're going to use the word mercaptan instead of the word alcohol. Now, mercaptan seems like a very odd sort of name. Doesn't sound very organic in some ways, but let me explain briefly where it comes from. Turns out that thiols react very quickly and easily with mercury. In fact, they are sometimes said to capture mercury, and so thiols are sometimes referred to as mercury capturers, or for short, mercaptan. So the word mercaptan is just sort of an old-fashioned word that means a thiol. So we're going to name thiols as alkyl mercaptans. So let's try this one first. What would we name this compound? Well, the name of the alkyl group you may recognize is a propyl group, but since it's attached in the middle, it's what we refer to as an isopropyl group. And since it has an SH on it, it's going to be isopropyl. Let's try this one. What is the name of this alkyl group that's attached to the sulfur? Well, this is one of those odd ones that I had you memorize earlier. It's a 3-carbon chain, but it has a double bond in it. This is what's called an allyl group. Hopefully you recognize that as an allyl group, A-L-L-Y-L. And since it has an SH on it, we're going to call it allyl. Let's try this one. Obviously a cyclopentyl group. So this compound is cyclopentyl mercaptan. So that's the common system. It's really only used for things that have a fairly simple alkyl group attached to the SH group. Let's now learn about the IUPAC system, which can be used for more complicated molecules, as we will see. How do we name thiols in the IUPAC system? Well, basically the same way you name alcohols, except we're going to put in this little THI in there. Instead of an alcohol, it's going to be a thiol. So we'll find the longest chain, number from the end closest to the SH group, and then name it as an alkane thiol, like ethane thiol, methane thiol, to butane thiol, and so on. Let's try this compound right here. Obviously 3-carbon chain, so it's going to be propane. Has an SH on it, so it's going to be propane thiol. The SH is not on the first carbon, but on the second carbon, so it's going to be 2-propane thiol. Let's name this one. Same one we saw a minute ago. Obviously it's a propane group, except it has a double bond in it, so it's propene. And it has a thiol group on it, so it's going to be propene thiol. But we need to indicate two things. Where is the double bond and where is the SH group? Obviously we're going to number from this end, so that's 1, 2, 3. The double bond starts at carbon number 2, and the thiol is at carbon number 1. So it's 2-propene 1-thiol. Just like if that were an alcohol, it would be 2-propene 1-ol. And this is obviously cyclopentane with a thiol group on it, so cyclopentane thiol. Now, I'm going to ask you to draw this structure, so pause the video for a minute, see if you can draw out that structure, and then we'll come back and talk about it together. Hopefully you have figured out that it's a 5-carbon chain with a double bond at carbon number 3, an SH group at carbon number 1, a methyl group at carbon number 4, and a bromine at carbon number 2. So here's the structure. 5 carbons, 1, 2, 3, 4, 5. Thiol group at carbon number 1, bromine group at carbon number 2, methyl group at carbon number 4, and a double bond starting at carbon number 3. So that's basically it for naming thiols. Nothing very new. It's essentially just like alcohols. How about preparation of thiols? We only have one we have to worry about, and that's simply substituting a halogen for an SH group from an alkyl halide. So here's an example. Starting with N-propyl bromide, reacting it with sodium hydrogen sulfide, that is a sodium positive and an SH negative. The SH negative serves as a nucleophile, comes in, attacks that carbon, pushes out the bromine, and we end up with the SH on the carbon instead of the Br. Here's another example, this time starting with hydrogen sulfide, not SH minus, but H2S. You remember that that also can serve as a nucleophile, not as strong a nucleophile, but still a pretty strong nucleophile. And again, it's going to replace the chlorine this time on that carbon and going to put an SH on there. So that's really all there is to preparation of thiols. And lastly, let's talk about reactions of thiols. Really, the only reaction we're going to worry about here too much is what's called oxidative coupling. This is a new reaction unlike anything you've seen before. What it does is starts with two equivalents of the thiol and uses some sort of an oxidizing agent, fairly mild, like I2 or O2. We don't want to use a real powerful oxidizing agent because then we would start to oxidize the sulfur, put oxygens on it, and so on. But if we just use I2 or good old O2, what happens is the two molecules of the alkane thiol link together at the sulfurs, so we actually form a sulfur-sulfur bond, and this is what's called a dialkyl disulfide. So we're forming what's sometimes referred to as a sulfur-sulfur bridge. By the way, this is important in biochemistry, so you will see this again when you take biochem. Or if you use O2, the same thing happens. You get the dialkyl disulfide. Now to balance it, if you're using iodine, because it only combines with one hydrogen, you need two of these for every one I2, and you get one of these and two HIs. When you're using O2, which combines with two hydrogens, then you need two of those for every 1/2 of these, forming one of these and one of these. But again, typically you're just going to write the structure of the thiol over the arrow, then you're going to write I2 or O2, and then you'll end up with a dialkyl disulfide. Here's a couple of examples. Cyclopentane thiol, when reacted with I2, gives dicyclopentane disulfide, or N-propyl sulfide, when reacted with O2, gives di-N-propyl disulfide. That's the talk for today. Thank you for listening.